My apologies for that. This class is Data Warehouse Basics. It's an introduction to SQL databases for analytic applications. My name is Robert Hodges, and I'm CEO of Altinity. We market ClickHouse for the open source database for enterprises. We help people do everything from doing training sessions like this one, all the way to operating it in the cloud and many things in between, such as 24/7 support, as well as certifying builds for enterprise use. So my background as far as qualifications to teach this class, I've been working with databases since 1983. ClickHouse is about the 20th database I've worked with, although at some point you tend to lose track. I have to say it's one of my favorites. It's a wonderful database, and I hope that in this talk I'll be able to share some of the reasons why I really like it. Speaking of the talk, it's being recorded. We will distribute the link after I remove the 5 minutes of dead time where I was muted. So you'll get that in email. We'll also send you the link to the slides. I've posted it in chat for those of you that were already on. You can go ahead and pull them down if you can read the link from Google Docs. We will be doing a lab as part of this class, so that's why we post the link in advance, because sometimes it's useful to go ahead and copy and paste things out of the slides. So with that, let's dive in. In the first part of this talk, what I'd like to discuss is what is a data warehouse. And for some of you that are coming here, you're probably hoping to dive right into the code. You're here to learn about ClickHouse. But I'd like to start with just talking about data warehouses in general, because it's important to understand what they are the kind of problems that they're designed to solve, how they go about solving them, and then also, you might say conversely, some problems that they're not well suited for, because it's also important to understand that as well. So let's just start with a problem. And probably maybe half of you have seen this already. What you're looking at in this slide is a snapshot of Google Analytics. This is a canonical problem that data warehouses solve. So what we do in Google Analytics is we're tracking every time somebody comes to a website and touches a page, we're tracking a bunch of information about them. What page did they come from? What's their IP address? How long did they stay on the page? Where did they go? Did they leave the site afterwards? So, and these can run into dozens or even hundreds of things that they get tracked. And so when somebody's trying to analyze the traffic on their website, what they're going to do is going to dig down and, for example, pick something like page views, so show me the top pages and metrics associated with them. And then they're also going to begin digging deeper, and we call this slicing and dicing. We'll talk a little bit about more of this as we go along, but the basic idea is you can go from this view that we're looking at with all pages, and you can begin to add additional dimensions. In this case, we call it a secondary dimension, where you begin to look at the data from a different breakdown. Take, like the root page, which is shown here, break it down from some other angle, if you will, and look at it in a different way. And you keep going back and flipping back and forth, because you're trying to get information about who's coming to your website, where are they coming from, what are they looking for, so on and so forth. What's most popular? This is a problem that data warehouses solve very well. And what we call this kind of processing is online analytical processing, or OLAP. And for those of you that have not heard about this before, I think it's worth taking a minute or two and just introducing the model, because as a way of, just as we have a relational model that governs databases in general, there's a way that we tend to think about the organization of data when we're doing OLAP. So the first thing is that when we think about the pages, we think, and the visits to them, we think about them having specific attributes, and we call those dimensions. So for example, one attribute of a page is its name. Another attribute or dimension of a page is the time when you actually arrived. There may be many others. Sort of, for example, what's the referrer? What's your browser type? What operating system was it running on? So those are dimensions. And the idea is that when we're looking at, for example, in that graph, we were picking a couple of dimensions, the page name and the date time, and we were using that to then collect metrics. So in this particular case, we're doing a very simple one. We're just counting the number of pages that arrived, for example, on September 14th. This we call a metric, um, and or sometimes an aggregate, because we're totting up some number and or aggregating it in a particular way. There are many kinds of aggregates, and we'll go into them, but they're everything from max value, min value, sum, unique, sort of unique values, different ways that we can tot these things up so that we can provide useful information. It's also important in OLAP that you may have many dimensions, but at any, like the landing page, medium, source, those are other attributes of a page visit. But for this particular view that we were looking at, we don't care about them. So they're dropped out, and then the page views are counted up only for the dimensions that we've selected. So I hope that makes sense. We'll keep coming back to this because it's a really important point and goes to a lot of the organization of data warehouses. So if we're going to solve a problem like this, there are some interesting technical challenges which cause data warehouses to be designed differently from other types of databases. So the first thing, and this example of uh, analyzing the visits to a web page illustrates it very well, is you may have a huge number of visits that you have to sort through. So for example, you could, like in the case of Google, they have thousands or even millions of users potentially who are looking at this information. It needs to be split up by user. And then of course, for large websites, they have millions of rows of data. In fact, many, many millions, even billions of rows of data that they're interested in scanning. So this ability to scan and do aggregates or count up various measures is very IO and compute intensive. And so we're going to need to have special technology to deal with that efficiently. Another thing is that we can swiftly change the dimensions that we're looking at and the measures. And we often do this interactively. This is important because it means that traditional ways that databases make things faster, which include caching data in advance, having indexes that walk you down to the data, specific items that you need, or pre-aggregating, in other words, pre-calculating some of the values, they don't solve this problem very well because they all assume that you know in advance what people are going to do, or that it's something they repeat a lot, which is the case with caches. So being able to handle that is also kind of tricky. And then the final thing is we need these answers really fast. In the case of doing web analytics, if we get an answer back in more than a couple seconds, people are just they're going to leave after a while because it's just too painfully slow to sort through this data, do different kinds of queries, flip from page to page. And in fact, it's not just people, sometimes machines are asking these questions. So for example, we could be based on web analytic information related to somebody's visits, we could be deciding to put a pop-up on their page. And in that case, we need to answer in less than 20 milliseconds. So these are very significant technical challenges which data warehouses are designed to solve. One of the key ways that they do it is they store the table data in columns. So this may not seem like a big deal until you think about how is a database like MySQL or Postgres or in general Oracle organized. Well, the traditional organization of a relational database is to store data in rows. So for example, if you have an invoice, you often have a table which is going to hold the invoice header information. It's all one row. If you're holding the data in a you have invoice line items, they're all rows as well. You translate that to this to this example that we're looking at. What that would mean is all the information that we're storing for each site visit is going to be stored in a single enormous row. So data warehouses don't do that. They instead store it in columns, and those columns then have a sort ordering, or the sort of table has a sort ordering, which ensures that all the values are sorted the same way across all columns, so that, for example, if we go to the third row, we can basically select the values for all three columns that are highlighted here. So this is a really important organizational choice for data. We also use SQL to fetch the data. So this is another really important characteristic of SQL data warehouses is they use the same SQL. And in fact, excuse me, the SQL we're looking at would most likely work perfectly well on MySQL, or not, maybe not so much on Postgres, but it's pretty close to standard SQL, and most databases would run exactly this query or something like it. And when we look at the query, we can then see things like, okay, we've got the dimensions, so we have the page and the date. We have the number of visits, we have the average time on page. These are your measurements. We can filter the data, so we can get it between, for a 2-week period between the 10th and the 24th of August. And then we have grouping and sorting. So the grouping is basically picking dimensions to group by. And in this case, it means any other dimension is ignored. And then we're ordering the data so that we'll show it, in this case, by the date of the and then the number of visits. So this is another important characteristic of SQL data warehouses, is they use, as far as possible, standard SQL. Now, when we start to process a query like the one that we just saw, this is where the column storage becomes really important. So the first thing is that when you're doing a query, if you only refer to a few columns, and in that previous example there were 4, you only pay, in some sense, for the columns you read. Because what you can do is, since the columns are just organized in separate files as basically big arrays, you only go open the files that contain the columns you want. So in other words, you're going to have a relatively, you're going to have, if you had, for example, a table, and the example I was choosing right here, I had 109 columns in the table. If I only selected 3 or 4, I'm really only reading 3 or 4% of the data. So that's a significant reduction in the amount of data we actually have to read. There's another thing that's really important, is that we compress data. And these blue lines you see in the graph reflect the amount of compression. So what that means is that even if you read a column, because it could be very highly compressed, you may in fact read only a tiny fraction of the actual uncompressed data. So this again makes things very, very efficient. And in fact, the reason that this compression works so well is because we're storing data in columns. So what we have, for example, is if we have, for example, like time on page, that's a floating point number. Typically, we're going to have a bunch of floats that are stored in an array, and we can now pursue various ways to optimize these. Or we could be storing the date time when they arrived, or we could store the session ID if that were relevant. In general, what ClickHouse does, it gives us 3 ways to compress data, and data warehouses in general for a number of years have done this. The first is by selecting an appropriate data type, by keeping it kind of small. So for example, if you're talking user sessions, you might have a very large number because they could potentially be they could have many numbers. If you're choosing the number of people in a taxi, you might just use a byte, because it's unusual to have more than 255 people in a taxi. Second thing we can do is we can apply codecs. So a codec is a transformation that we apply to the data so that we don't store the numbers, but instead store some surrogate. So for example, there's a codec called double delta, where what we store is not the numbers. Say, imagine we had something like times, time of day being stored. We could store not the number, not the change in the number, but the change in the change on the number. So for numbers that are slowly increasing, this results in a huge savings in storage. And then finally, we apply compression. Compression is different from codecs. It doesn't know anything about the data or its values. Instead, what it sees is just a string of bits, and it basically recognizes patterns in it, takes them out and reduces it to a much smaller string of bits. ZSDD is one compression algorithm that's supported that we'll be talking about today. LZ4 is another one. So the results can be phenomenal in some cases. So these are compressions from real data. This is airline data, which we'll be using for the labs. And when we apply different types of compression, for example, the airline carrier, which is a 2-letter code like WN or AA that designates the airline, just by putting LZ4 compression on it, we take out about 94% of the data. We can also do a codec on it, which is we convert it to what's called a dictionary lookup, where instead of having a bunch of airline codes, we store them as little integers, and then we apply compression on that. That makes it even smaller. Other examples you can see here that illustrate that we're getting compression levels that are often hundreds of times smaller than the uncompressed data. Of course, not everybody's perfect. Sometimes you have to play around with numbers a little bit to get reasonable compression. And this last one is an example of something we would go look at to see if we could compress it a bit and make it smaller, either by applying a codec or a different compression. So what this means is with compression, it becomes very, very cheap. Between the columns and the compression, it becomes very, very cheap to look across all of the values in a table or very large numbers of them. So that's the key thing we're looking at here. There's another thing about column storage that's a little bit more subtle, but it has to do with the way that hardware works, particularly Intel or AMD processors. So what will happen is we have these column values. They're going to be laid out in, when we read them in and uncompress them, they're going to be laid out in main memory as just an array of values. So for example, for taxicab passengers in a taxicab, we'd have an array of unsigned 8-bit integers. Now, what will happen is when data is actually loaded into the CPU, into a core specifically to get processed, it's going to get pulled in and stuck in a register. But in the meantime, it's also going to populate one or more caches. So we have what's called the top level one is the L1 cache. And this is a cache that the CPU, whenever it gets a reference, for example, if we read one passenger value when we're doing a sum, when it looks to do the next one, it will, but rather than go all the way to main memory and load that value, it'll pull it out of the L1 cache. So what happens is by lining these things up nicely in arrays, it means that in fact, we can pull a bunch of these guys in at once. We might get, like a dozen of them, and then the registers can process them very quickly because there's about a 50-to-1 difference in going to main memory. There's one final thing has evolved over the last few years, which is CPUs know that data sometimes has this property where there's a bunch of array values. So they have what are called SIMD instructions, single instruction, multiple data. And what they do is they can take our taxicab values and they can load them into a special register. And for example, if we're adding them up, we can add them up 8 at a time, as opposed to, so take like, it loads in like a 64 128-bit integer, gets loaded into that register, and whatever mathematical operation we're doing, you just do it all at once. So this is another more subtle way that column storage is very beneficial for allowing us to process data very efficiently. And then there's a final thing, which is that when we do these aggregates, in other words, these measures, say like an average, it turns out that most of them distribute extremely well. So we have let's imagine that we have these time on page values, which is something you're really concerned about. We have a huge number of records, so many that they can't possibly fit on a single host. We instead spread them around on multiple hosts, and you can think of this as being something where we can partially aggregate. If we want to compute a sum, we go to each chunk of data, compute a weighted sum, and then that all gets centralized in a single point, and then we compute the full sum. What this means is that these are operations that could be parallelized very easily. So in fact, what we find in data warehouses is that they just parallelize like mad. So when we have a query that comes into a data warehouse cluster like ClickHouse, but also this is true in many others, they'll arrive at some host, they'll look at that host, will look at the query, it will split it up into pieces, send it to a bunch of other hosts to get served. And then within that host, we will also split up the query and basically farm out parts of it to different cores, so that we're parallelizing across hosts and also across available CPU cores. The result is that we can get, particularly if the queries are mostly doing IO and a bunch of IO and measurements, we can basically get linear performance just by adding more hosts. And this table that's shown on the right side gives a graphical illustration of that. This was a cluster I set up in Amazon, doing a kind of heavy query on 173 million rows. And you can see that even when the caches are cold, even when we're pulling all the data in fully from storage, as we add shards, which is to say split the data up into pieces, we basically get linear increase in performance. So 2 shards is twice as fast as a single shard, 4 shards is twice as fast as 2 shards. And we see this behavior in this particular case, regardless of whether it's hot or cold. So regardless of whether we go to storage or not. So this is, these are, sort of, whoops, lost my place. 1 second. So we can kind of sum this up in the following picture that shows this effect of reduced IO and parallelization, just to give you kind of a, like to grok just how big the efficiency is. So in the example that I was working with when I was running the numbers, it was using airline data. And if we stored it in a conventional database that couldn't, that had to put everything in rows and couldn't compress it, I would have to read 59 gigs of data. So that's this big ball, whose volume represents 59 gigs. You can think of it as Jupyter. So now imagine I read 3 columns. Well, that's only going to require me, because I have column storage, I only have to read 3% of the data. So it's 1.7 gigs, 97% just dropped away. If I read 3 columns and they're compressed, well, it turns out the compression was pretty good on these. So now I actually only have to read 21 megs of data for storage. You can kind of see where this is going, that now we're talking about, even if the storage is far away or slow, this is something that just isn't going to take very long. A common desktop drive would be able to read this data in about 1/6 of a second. And then finally, we can go ahead and, by parallelizing, it means that each of the threads, and in this case I used 8 threads, each one only had to read 2.6 megabytes, and then it could do whatever computations were on top of it. So as a result, we get the IO that's being processed by each processing thread goes down phenomenally. In this case, if you run the numbers, it ends up being a reduction of about 22,000 times just in this particular example. What this means is we can now afford to scan very, very large amounts of data because we're thousands of times faster than a conventional database. So I hope that makes sense. Here's just an example of one of the types of queries that I was running on using a pretty underpowered VM. I think it had about 8 vCPUs. It was using network attached storage, Amazon EBS, and I get my answer back in this case, 221 milliseconds. I had to process about 10 million rows. It was smart enough to knock some of them out. So we get this phenomenal speed up. And if you look at the actual speed that it's scanning data, it is very, very fast. So this is kind of a quick tour of the architecture of data warehouses. I hope this makes sense so far. Let's look at one final thing before we depart from this, and that is the no free lunch problem. Okay, so this type of design with column storage, with compression, with parallelization works great if you're reading off very long tables, if the tables are very wide because you don't pay for the columns, if you have open-ended questions where you don't know in advance what you're going to ask, because we don't need indexes, we can just scan the data using brute force. And if you're doing a lot of aggregates, so you're not saying show me the data, you're saying tell me something about it, like how many people visited my page. You're not asking to see all the page visits, you want to know how many people. So if you have a lot of aggregates, all of these properties or any combination of them together, a data warehouse is going to work very well. Where it doesn't work is, let's say you actually did want to see the page visit data, and that was in fact your application. This would be the case if you were looking up somebody's basket or their session in in an e-commerce application, lots of tiny lookups. They're updating constantly because people are, you're changing session variables. There's maybe high concurrency because there might be 100,000 people navigating the site. And then finally, particularly if you're buying things or otherwise, doing transactions, consistency of the data is really important, and being able to avoid updating something, ensure that you're properly isolated from other people. These are all things that data warehouses don't do very well or even at all. So if you have problems that have these properties, chances are you want to use something like Postgres, MySQL, Oracle, Microsoft SQL Server, or any of a number of relational databases, or Redis for that matter, or MongoDB. But the point is, that's not a data warehouse problem. Okay, I hope this makes sense so far. Feel free to ask questions. You can put them in the chat box. I can see those, or you can put them in the Q&A box. What I'm going to do now is I'm going to go ahead and talk a little bit. I'm going to introduce ClickHouse and talk a little bit about how to get access to it, and then excuse me, and then we'll talk about tables and do a lab. So let's go ahead and talk about installing and connecting to ClickHouse. All right, ClickHouse. I assume that most people here have heard about it, but just in case you haven't, ClickHouse is kind of like, one of the ways I explain it is, everybody I think has heard of MySQL, very, very popular database. It runs, WordPress probably wouldn't run without it, but phenomenally popular, particularly for web properties and web servers. Another database is called Vertica. It's a very popular data warehouse, invented by Mike Stonebreaker and his friends. And it introduced a lot of really great innovation around data warehouse. And ClickHouse, you can sort of imagine as imagine if MySQL and Vertica got married, this would be their kid. There's no actually code copying. The code is not derived from them in any way, but they have similarities because we've chosen to solve problems. We had similar problems to those databases, and we've chosen to solve them in a similar way. So for example, from both MySQL and Vertica, we understand SQL. SQL is just good. So both sides of the family have that. Now, another thing that we have is just excellent portability. So MySQL is just a single process. You plop it down, you turn it on. ClickHouse runs anywhere Linux does, so everything literally from an Android phone up to racked equipment to to pods and Kubernetes to Docker containers, to VMs. It runs great in all of them. If Linux runs there, ClickHouse does too. It also runs on Mac OS X, but we don't really focus very much on those builds. Another thing that we share with MySQL is we're open source. In this case, Apache 2.0, which is better than the MySQL licensing, because you can take the code, you can embed it in an application that you ship. You have more freedom to do what you want with it. Now, from the data warehouse side, we have some important characteristics. First of all, we use what's called shared nothing architecture. So we basically have a bunch of nodes. The nodes have compute, they have storage, and they're connected across a network. If you want to make the cluster bigger, you add more nodes, and they talk to each other over the network. We store the data in columns with the concomitant features of things like compression and sorting and so on and so forth. We're very good at parallel and vectorized execution. So when I say parallel, I generally mean processing across hosts. Vectorized execution is particularly when we're on a single core, where what we're doing is breaking up the process of an array into smaller chunks, farming them out to individual cores, and then as far as possible using SIMD instructions that I mentioned before to process them as quickly as possible. And then finally, we scale to many, many petabytes. So there are ClickHouse clusters out there that run as many as 500 nodes. That's the largest I've personally heard. There are rumors that there are Chinese websites Chinese sites that are running 1,000. And the final thing about ClickHouse that it really grabs people by the collar is that it's incredibly fast. So, and we'll show some examples of that as we go along, but the code, beyond the features that we discussed here, the code is just designed for speed. So it's written in C++ and really, really honed. So here's how you get this. If you're on Linux, and that's typically where I run it, you're going to do a, for example, this is Ubuntu. We're just going to do apt install. And there's some commands up here for those. I think most people who run Ubuntu are pretty familiar with these commands. We're going to load the repo for ClickHouse. This is the community repo. We're going to tell apt about it. And then we're going to go ahead and run two commands. We're going to do an apt install, and -y means just don't ask me any questions, just go ahead and do it. And then ask for ClickHouse server and ClickHouse client. ClickHouse client is a program that talks to it. And then we'll run systemctl start. So, and when we install ClickHouse, it does not start automatically. This is basically to protect you against yourself. It means that you can install the software, pre-position it, and then start it at the right time for whatever else you're doing. There's a very good description of this in the community docs, and the URL is here. There's another way, which I recommend if you're running a Mac, or if you just don't want to worry about dependencies, maybe you don't have root access on your machine. You can also run it in Docker. It runs great there. So here's an example of Docker run. I made a directory to put my data in, and then I'd run the Docker run command. This looks a little bit gnarly. And the reason is we're giving ClickHouse just a little bit of information that it needs to run. First of all, changing the number of open files. It set that U limit to something big, in this case over 250,000. We're also, the minus volume is telling ClickHouse, hey, this is where to put your data. And this means if your container gets zapped or you sort of wipe it out, you won't lose your data. And then finally do port mapping. So these are the two most common ports that people use to connect. So we just make them visible to the host. So this is a great way to run ClickHouse either on Linux or on Mac OS X. It'll come up if you have a normal network connection. You'll get it downloaded and start in about 60 seconds. And here's how to connect to it. So the ClickHouse client is the standard client that people use. When I have a choice, this is the one that I go to. It runs on the command line. It is great. These are examples of invoking it. So, here we're the first one, we're fully secure. Using the username and password. The passwords can be hidden, of course. If you're running it locally, you run unencrypted and you have a default user. And in fact, if you're running on your, the behavior is similar to MySQL. If you're just running on a laptop, for example, you can just say ClickHouse client and it will connect. It only listens on an internal, on a localhost port, so it's not exposing ports to the outside world. There's also, besides the ClickHouse client command, there's a really nice built-in web UI. This is something, a plaything of, or sort of a feature that Alexei Milividov, the original designer and lead committer of ClickHouse, put in. I use this constantly. It's really handy. This is something where you can basically just connect to your ClickHouse on its HTTP port. So that's either 8123 or 8443, and then it pops this this little screen up. You can enter your user and your password, and off you go. And you can run any queries you want. So this is super useful for connecting to ClickHouse. One final question is there cloud service for ClickHouse? Yes, there's at least 7 or 8 by my count. The biggest ones are in China. There's at least 3 really major ones. Places like Alibaba, Huawei, and Tencent all run managed ClickHouse. Yandex runs it. We run it at Altinity in Amazon Cloud in the US, where there's also some other ones, but they're pretty minor and haven't gotten very far. If you want to find out more about ours and are running in Amazon, just hit that URL there. But there's definitely lots of options. And one thing about the both ours and Yandex, I can't speak for others, is we run the open source builds. So you're not like, it's not like you're going in there and getting locked into a build that you can't use outside. You can, if you don't like it or you have reasons to move, you can move back to the community releases with full compatibility. So that's a quick introduction to installing ClickHouse. It's exceedingly simple. I do it all the time. You can blow ClickHouse away and bring it back in a few minutes. It's really handy. So let's do a short section now on creating tables. Just talk about how tables work in ClickHouse. They're basically like data, so ordinary SQL tables, but with some differences because this is a data warehouse with column storage. So if we're making a table, we're going to use a create table command, just like any self-respecting SQL data warehouse. So here we have the create table command, and this shows the syntax. There's also a drop table if exists. So that's how you get rid of it. Let's just look at a specific example. This is what it really looks like. And the first thing you'll probably notice if you're a SQL person is you'll notice that the table columns have different type names. So for example, we use string and int32 instead of, int or varchar or char, float 64. We would use float for that, or long. So we don't have this, we have equivalent data types, but we don't necessarily use the ANSI names. We also have this really important property called an engine. And this is a bit like MySQL, but if you use MySQL, you've probably forgotten about it because the engine now defaults to InnoDB. And most people, almost everybody just uses that. But in the case of ClickHouse, there's lots of different table engines. And they all have different purposes. The most common one that we use in ClickHouse is called merge tree. And that is the go-to table for very large amounts of data. The merge tree needs to know a few things. It needs to know how to break the table up into pieces, because if you're using merge tree, it's because the data are likely to be large. So we need to give it what's called a partitioning key. And in this case, we're breaking up the table by months, that we're passing it through a function that takes our date and turns it into a year and a month. And then we have an order by, so telling us tell ClickHouse what's the sort order on the table. Again, you must have this. It can't guess because it doesn't know what your data are or what you're doing with it. So what happens in this table is if you go look underneath, the table is broken up into parts. And you can actually see this on the file system. It's a completely open, pretty open format. And within each part, if we had that table definition from before, all the rows in each part would belong to the same month. If we had a lot of rows in the same month, we would end up having multiple parts. ClickHouse fills the parts to a certain size, and then it'll make more parts. In the background, it takes care of trying to find a part size that optimizes the read performance. So it will reshuffle the data over time to get you the most efficient part distribution. Within the part, we'll also see that the columns are all supported by the in this case, dev ID and mdate time, because so what that means is the data has this preferential sorting, and that has some interesting consequences as you get into schema design, because, for example, some sort orders allow you to access the data more efficiently. Some sort orders also compress better because they tend to, they may line up the data in a way that there's less variation. And then finally, there's a thing called a sparse index. So the sort key is also used to construct a small index. This index, we call it sparse because it doesn't have an entry for every single value in the every single key value. This is not like a B-tree index or something like that. Instead, it's a way of accessing data. Just one second, please. Apologies, I'm back. So the sparse index is, and the reason we don't, the sparse index does not have a value for every key, is that we want this index to fit into memory. So in fact, that by default, the sparse index only has an entry for every 8,192 rows. And what it does is it allows you to access blocks of data within the part. This turns out to be very well organized for reading, but it does have the side effect that if you actually want to read a single row, ClickHouse by default is going to go read 8,000 of them together. Now, granted, the I/O is much faster, but this is one of the reasons why we don't use ClickHouse if we have something where all that we're doing is looking up single rows. For that, use Redis. So anyway, this is the format that you see under the covers. So there's some pretty simple commands for, once you've created a table for finding them and also finding the databases they live in. ClickHouse has a database organization very similar to MySQL. In fact, all of these commands would work perfectly in MySQL. It's ClickHouse has copied the dialect. So show databases shows the different databases you have in ClickHouse. A database is just a folder for holding tables. You can see across them, you can join across them. There's no issue there. The show tables command will show you the tables, and if you say from, it'll show you a particular database. Otherwise, it'll show the tables in a database called default. And then describing a table shows the structure of a table. So what are the columns? What are their data types? Things like that. So one thing that's kind of important when we're talking about tables is if you studied databases, particularly if you studied them a few years ago, you would learn about third normal form, which the idea with third normal form is to just completely eliminate duplication in your data. So if you have, like information, this on-time table in the middle, it's information about flights. So, and the flights have an origin, which is an airport. They have a destination, which is an airport. And so there's a bunch of information about airports. We put that in a separate table. We then refer to it using what's called a foreign key reference. And this ensures that we can go ahead and change the airport data, and then it'll be properly reflected by every single user. It's also something that minimizes the amount of storage, because if we had actually put this airport data into on time, as we say, denormalizing it, it would use a lot more disk storage. That was important back in the days when disks were really slow. It's also really important for row stores where there's a big cost to having extra data in the table, but we are a column store. So as a result, this full normalization that you're looking at here is actually an anti-pattern. You tend not to do this. Instead, what we tend to do is denormalize data so that we end up with something that is a very large fact table. And then there may be occasional things that we need to refer to. We'll put them in separate tables, but there's no notion of a foreign key or a, like where we enforce consistency between the airport table and the on-time table. That's just not how we work. We assume that you can load the data if, that the data came from someplace that was already consistent, or you've taken care of making it consistent, and you load it into the data warehouse, and then you're free to do any kinds of queries that you want. So there's no, we're not forcing you to define referential integrity. We're not maintaining it. We're also not forcing you to. There's some also side effects of this inside the database format itself, like creating indexes. None of that happens in ClickHouse. So to make a long story short, you just don't do this. You don't organize data in this with the third normal form. You instead have these big fact tables. You have some number of dimension tables, and then you're able to join them, but the idea is most of the data is in your fact table. So this concludes the first part of this class, and what I'd like to do is take a couple minutes and invite you all to try connecting to ClickHouse. So we have a really simple exercise here, and I'm going to show, so basically, if you have ClickHouse already, what I'd like to suggest is you go ahead and just connect to it, but I'll give you some information. What we want to do is connect to this ClickHouse instance, which is our public, it's run in Altinity.cloud. It's just a public database instance. I'm going to go ahead and type it into the to the chat. So if you punch that link, it should just pop up in your browser. Now, if you're behind a firewall, or working in a company that has very strict network security, you may not be able to do this. in which case I don't have an easy answer. We sometimes have to go change firewall rules to get this to work, but you can go ahead and type this link, and then you should see, it should just come up with the username demo. If you want to then issue queries, you'll have to type the password on the right, and you just type the word demo there. So it's demo is the username and password. Go ahead and try that out. So just punch that, bring it up in your browser, and then you can start to run queries. So I'm going to run a query here. So I'm going to select the value 1. This is the simplest. This is hello world for a database. So it selects 1. So why don't you try that? And as soon as you're connected, just try some of these exercises. So you've got the commands that we saw in the slides. That's why I posted the link. I'm going to post that link again so you can get them if you need them. So go ahead and try this out and let me know if you're able to do some of these exercises. We'll give you 3 minutes to do it. It's not very long. And if you've used MySQL, you'll do it very quickly. Okay, I've just posted the slide link. Could somebody just let me know in the chat, or if you're able to do this, just confirm you're able to get in and try some of these exercises out. It's working. Okay, Luis, great. Awesome. So, and just going back, here are the commands that you can use to show the databases, show tables. And there's a table called OnTime, which is kind of fun to look at. So you can do a describe. So I'll give you a couple more minutes, try it out, and we'll look at it, and then I'll show you some of the answers. Okay, question, where do we put the password? Yes, let me show you. So so here you are, you've issued this command to go to this play interface, or play UI, that's what we call it. Your username is in the column that I'm now highlighting. The password is to the right of it. We're a bit parsimonious in the interface. So we simply type the word demo, D-E-M-O, and it appears as 4 dots. And then at that point, we're set to go, and we can do the homework exercises. So I hope that's working. Let me know if it's not. This is a great way. By the way, this endpoint is publicly available. Feel free to come to it anytime, try out these exercises. And in fact, speaking of the exercises, let's just look at them. So showing databases, what do we do? So we do show databases. We're gonna see how many databases are accessible to us. All right, so we just get one called default. This account is really locked down. There's actually several other databases here, but we don't show them in the demo account because we're locking down the security. It's just meant to do simple exercises. We can do show tables to see what tables are available to us. So there they are. There's one, airports to trip data. The one that we wanted to go see in detail is called OnTime. So we're going to describe OnTime. And here it is. So we run the description, and then it basically just gives us, much like a describe command, describe is a pretty standard SQL command supported by most databases that I'm familiar with. It shows you the exact, the columns in column order, their data types. We haven't done any optimization on this. So for example, we don't have defaults, we don't have comments added, we haven't added codecs or changed the change the compression, so most of this stuff is blank. But this is the table that we'll come back to when we do the exercises for to illustrate the select command. So we'll come back and play around with this. You can see it's basically the date of the flight, who was the who was the carrier. This table has U.S. transportation data for every single commercial flight over the last 30 years or so. It ends in our data set ends in 2020, but it's a bunch of interesting data. Okay, I hope you're able to access this. This is, as I say, that I love this little Play UI because it's every ClickHouse server as of about November of last year now supports it. So you can pop in. This is a really quick way to get in and try to and do things on ClickHouse. Let's go back, and we're now going to pick up the conversation and dig a lot more deeply into SQL. And again, feel free to ask questions if you've been working with ClickHouse. Happy to answer them. If it goes beyond things that I know about directly, we can of course refer you to more additional sources of data. So speaking of data, let's talk about insertion. We aren't able to test this because we only have read-only access to this. We have read-only access to this test data, but I can tell you how it works. So let's dive in. So this is a SQL database. So as a result, when we're adding data, we're going to use the insert command. So this is, and the format or the way that this works is pretty similar to the way SQL works by default. So here's an example of, I've got this S data, that's the table I created in a previous example. I'm sticking some information into it. And what I can do is give it, I say insert into table, give the name. Normally I would be a good kid and put in my column names so that so that there's no ambiguity about where it's supposed to go. And then I say values. And at that point, I can just give tuples with parentheses around them. And I can do as many of these as I like. There's just one thing. This is not how we normally insert data into ClickHouse. So the first reason why this is an anti-pattern is that I'm only inserting 2 rows. So ClickHouse, because we have column storage, really wants to have large numbers of rows inserted at once, like 100,000 would be a fine number. And the reason for that is that since we're storing things in columns, every time we have a different column value, we're going to have to open up and write a different file. In fact, in the case of ClickHouse, by default, 2 files. So to amortize that and to make it worth doing, we'd like to add a lot of rows at once. So we don't typically, first of all, don't typically insert a small number of rows as we show here. The second thing is that most data doesn't naturally come in this format. So in fact, what we'd like to do is submit it directly using whatever format it normally lives in. So here's an example. Let's load data that's CSV with column names. So this is a very common format for large data sets. JSON is another common format. Parquet is another common format. What we're going to do is we're going to have the file which contains all our data, maybe 50,000 rows. We're just going to cat it into the ClickHouse client. So sort of print it through standard in, and then ClickHouse is going to apply an insert command, but we're going to use this format CSV with names. And what that's doing is telling ClickHouse, hey, this is CSV, and by the way, the first line is column names. So go ahead and use that to figure out what columns it belongs in. This is way more efficient and allows us to insert the data in bulk. So ClickHouse, in fact, has a number of ways that we can, many formats that it supports. I'm just going to show you one other interesting way that you'll commonly load data, at least when you're reading files, and that's to load it from S3. So ClickHouse reads S3 compatible storage very well now. So here's an example where we're pulling that same exact file, except in this particular case, we're using something called a, well, let's explain this command. So we're inserting into a table called readings. What we're inserting is the result of a select statement. So we're selecting all of the columns. This is a little bit unusual. You normally don't say select star, but this is one case where we do, because the columns there might be a lot of them. But what we're then selecting from is called a table function. It's called S3, and it just takes a bunch of values that tell us where to find the data, how it's organized, and then it reads it in. So this actually works very efficiently and allows us to read large amounts of data. ClickHouse, as it turns out, and as we document, as you can find out from the documentation, allows things like wildcarding, for example. So you could have a big bucket in S3 or MinIO. That's another thing that ClickHouse can read very well. It can be living in the bucket. You just give a wildcard. You can also, there's a setting that allows you to get ClickHouse to insert in parallel, and then you can just blast up a bunch of files simultaneously. This is a great way to bulk load data. There's a final way to load data from ClickHouse, and I can't really illustrate it because it's relatively complex. We cover this in ClickHouse 101 as well as a bunch of webinars. It's to read from Kafka. So for S3 is great for bulk loading, or files in S3, you're typically bulk loading data. You're not necessarily concerned, you're not necessarily getting it directly from the applications that are producing it. Kafka is different. So Kafka is like messaging on steroids. And in cases where you want to be able to receive the data as quickly as possible from the producers, Kafka is great. So what will happen is, and this just shows the connection between what we do to integrate with Kafka. But if you imagine you have monitoring data that's coming from a bunch of VMs, each of the VMs can have, for example, could have a collector, which is just writing straight to Kafka. It will arrive in a topic, we'll read out of that topic. And what ClickHouse does is it has another table engine, which wraps the topic and makes it look like a table. And it's a table we can select off. And then we use a feature of ClickHouse called a materialized view. This is another form of table. And the materialized view knows how to fetch rows when they arrive in another table. It's kind of like an insert trigger. So it's connected to it's selecting off the table engine, which encapsulates the topic. And then every time it selects something, it sticks it in a target table, and then you can just query it. So this is built-in integration that's available in ClickHouse, and it's a pretty convenient way to get data out of Kafka. So that is a very quick tour of how to get data into ClickHouse. There are many more ways. It's very interesting to look up the insert formats. In particular, there's dozens of them that are supported. As I say, JSON, Parquet, CSV, Cap'n Proto, you name it, anything that's common, we tend to support it. And ORC is another one. So it's pretty easy to load data. So let's get to the final part now, which is kind of the heart of using ClickHouse, and that is building reports using Select. So let's just dig in. So if you haven't met with SQL before, I think most people here have used SQL and are quite familiar with it, but here's the general format of a select command. So this is going to pull some number of columns from some table where we have filter condition, grouping in some way, ordering or having order by limit. These are all, I'll illustrate all of these conditions as we go through. There's also, you can join, so you can actually join, grab data, incorporate data from other tables. I should probably include that in this example. And the reason that the select is so important is for analytic systems, most of what we do is once we've got the data loaded, we want to look at it. And so select allows us to fetch the data in ways that then lead to interesting displays. So for example, these are just two displays in Superset, which have underlying queries. The first one is showing the number of flights between the most popular airports in the United States. And then the second one is just a list, like what's called a word cloud, which is where the words are based on the number of flights from the 100 most popular airports. in the United States. So that's so these SQL queries, if we get these SQL queries, we can then build these things very, very simply. So let's dig in and find out. But first thing, there's another anti-pattern. So if you were, you might have noticed that when I showed the insert command, I said we're inserting from select star, and I said that was unusual. It really is. We rarely, when we're, for example, with the airline data set that we're going to use for the lab exercise, we rarely use select star, because what that means is that's a table with 109 columns. We're going to get every single column, and we're going to get 196 million rows. That's almost certainly not what we wanted, unless we were trying to dump the data to take it somewhere else, in which case there's way more efficient. There's other ways that we can do it that are more efficient. So what you're looking for in these data warehouses is you're looking for insight. You're not specifically looking for data, although later on you could drill down to very specific parts of it. So what we're going to see is queries that look a lot more like this, where we're going to ask the question, which carrier had the most canceled flights in 2017? So ClickHouse SQL supports for select statements, supports just about every select feature that you commonly use. There's a few outliers, but they're getting patched in as well. For example, window functions are new. They're now arriving in current releases and will get better quickly. Common table expressions are another thing that's recently arrived. But this is SQL that would run, this or something very similar to it would run in just about any kind of database. And the way that what we're doing here is we're looking for the most canceled flights. We have a couple dimensions by carrier and by year. We have a measurement, which we're calculating as the sum of canceled flights. There's you'll see this if you play around with the data, there's just a 1 for any flight that was canceled. And then we divide that by the total number of flights from the table. So we have range filters to be able to select, only 2017. Grouping, that sort of groups our dimensions. Measurements to things to knock out certain measurements that are uninteresting, so on and so forth. We'll go through and look at each of these, but this is the kind of thing that you're looking for, and this actually returns a relatively small amount of data to your client. So to understand group by, if you have not used this before, it's a really powerful it's a really powerful command, and what it fundamentally does is it tells who your dimensions are. What are the dimensions I care about? So when I'm looking for these canceled flights, I am looking for flights by carrier, so by airline carrier, and by year. So that has to be in the group by, and then what that does is that means that the columns, then you can think of those as the dimensions. Everything else, every other column must be an aggregate. So what that means is it must either count something or perform a calculation or do some other transformation on the non-dimension information to present it in the query. And we'll see an interesting example of where there's some things that are we may show things that actually aren't aggregates, but we need to make them look like something, because if they're not in the group by, they must be an aggregate. So this is a really important command, and the most common syntax error in ClickHouse probably is to forget to put stuff in the group by, and then it spits at you and says, I don't see this in the group by and I don't like it. So if you've used other databases, you'll find that the aggregate functions that you know and love there are all supported in ClickHouse, the standard ones. So there are things like count all the way to through sum. These are things that are in the SQL standard, and every single database supports them. There's also a really important aggregate called any, which is the first value encountered in a group. I think I have an example of that coming up. ClickHouse supports this, but unlike the other ones, it's case sensitive. Databases like MySQL and as far as I can tell, MySQL and Microsoft SQL Server will aren't case sensitive. So it's a little bit of a variation. So here's an example of using them. So we're going to get a bunch of information about arrivals by carrier. So we'll count the number of flights that they have. We'll count the number of distinct destinations that they flew to. And this is over the entire data set. We'll get the average arrival delay, so on and so forth. And then the number of minutes that people wasted in total. So this is an example of using aggregates in a pretty common way. So again, these are queries that would run in any other database. The main difference here is the syntax is not different. In fact, we definitely don't want to make it different. The difference is that even on an enormous data set, this is going to run very quickly. So it's worth thinking a little bit about the dimensions, because there is one that is really special, and that's time. So one of the things about large data sets is it's very, very common for the data to be time ordered in some fundamental way. You think about measurements coming from devices. You think about log records being produced by Log4j or some other logging mechanism. They all have date times or dates and times associated with them. Think of trades in a stock market system. Think of visits to a web page. They all have time as an important component, and many of the analyses that we're going to do are going to make them interesting. We're going to include time, because we're going to look at, for example, how things changed over time. So we'll see this very, very commonly. You do not have to put time in ClickHouse. I want to be clear about that, but you're going to, time is going to come up again and again in your in this, and in fact, many BI tools, even if ClickHouse doesn't make the assumption that things are time ordered, many BI tools like Grafana do. So we're going to see this a lot, and what we'll often do is see time and then have it transformed in some way. So the time dimension for flights is the date. There's also a time as a time of day as a separate column, but we'll ignore that for now. What we'll commonly want to do is when we're breaking things down by months, we'll just pass it through a function and then get the month out of it. So this basically normalizes a bunch of dates to the first day of the month. So ClickHouse has a bunch of features to make it easier to work with time. So there's 3 different data types. So we have date, the one that we were just looking at. We have date time. This is like a Unix date time. So or Linux, as the case may be, it has precision to a second. And then we have date time 64, and that's precision down to nanoseconds. That was actually incidentally a feature that we implemented at Altinity. Many BI, date time is an interesting one because there are tools like Grafana that prefer that and are going to be trying to change things into this form because they expect to be seeing time series data, and they want to and they like to have that particular format. So in addition to these column types, which you can pick based on your use case, there are dozens of functions that then do transformations on time. So for example, taking a date and getting the year out of it. Normalizing dates, that's to start of, these all kinds of functions that do that. Functions like to YYYMM, that just today's date, if we ran it through, would come back as 202106, so 2021-06, so on and so forth. So these are all there. Regardless of what you're doing with time, you'll generally find that there's a suitable data type now and functions to do the kinds of normalization that you need. So you can just go look them up in the docs and try them out. So given that we have these, sort of the basic query with the group by, and we've looked at time, we can now start looking at where clauses. And again, we want to look at, so this is since it's the basic introduction, here's an example which shows how we can filter data using where. So there's a number of kinds of operators. So for example, for dates, there's a between operator. It's a very handy operation. And what this is doing is it's converting, it's saying, hey, find everything for the first 6 months of the, from the 1st of January to the 30th of June inclusive. Now we have to convert the dates to strings. ClickHouse and SQL in general doesn't do that magically in most cases. So we have a function to do the conversion. Also, we want to say, hey, the carrier is not equal to American Airlines, and we're flying to San Francisco, Chicago, or New York. So these are the types of, these are common operations. Just about every database on the planet that speaks SQL would do these or something very, very like them. So this basically says anything that we're going to look at before we can do our counts, they're going to have to pass through this filter. Otherwise, we're not going to consider them. So that will cut down the results enormously. ClickHouse supports all the standard SQL expressions, so which you saw, but things like in or between and or and the standard operators. So so these are pretty if you've worked with other databases, just about everything that works there is going to work in ClickHouse. Similarly, we can also use subqueries. So these are and these are exceedingly handy. So for example, if we're going to ask a question, answer the question, how many Alaska flights serve the same cities as Southwest, we're going to look for flights where the carrier is equal to Alaska. And we're, it didn't say this, but we're picking 2017 as the year. And then we're going to find all the origins and destinations that from Southwest. So this basically builds up a, it's going to go ahead and build up a result set, and we can compare it. So this is actually very handy. And one thing that the ClickHouse does do that not every database does is you can actually pass back multiple values. So this is a tuple instead of just a single value. Old style databases only allowed you to have one value. So these are super super helpful. And it turns out that if you're using in, ClickHouse is very well optimized. So this is an operator that runs very, very fast in ClickHouse, and is something that you can, is sort of your go-to if you need to restrict or filter queries. So here's an example of another exceedingly common type of query that then illustrates ordering of data. So we, in the superset examples I showed a few slides back, we have what, I mentioned we're looking at sort of traffic and number of flights from the most popular airports. So you normally answer that kind of question by what's called a top-N query. And the idea here is that you're going to do a select, you're going to group by one or more dimensions, and then you're going to order by one of your measures, for example, here flights, and you're going to limit it. And what we do is, what's important is we can order it. We can order the rows that come back by flights in descending order. So that's going to mean the biggest ones are going to come back first, and then we put a limit on it. So this basically gives you it's going to give you the top 10 busiest airports by departure. And there's an interesting feature here. This is aggregation function any. This doesn't really do a numerical calculation. It just grabs one of the values from this column, and it's useful if you have denormalized data that has a bunch of correlated values. So we have the origin, that's the airport, and then we can also print out the origin city name and origin state. These are present in the rows as well. And so ClickHouse will just take our word for it that that's what we want. It'll grab one, and then we get a nice display. So this top-N query, this is one you'll use constantly, particularly when you're building dashboards. Another interesting SQL thing that if you haven't used data warehouses, and particularly analytic queries, is having. So we use the where clause to prevent data from reaching the query in the first place. That means that it's not something that we want to even look at. So for example, we only want to look at data for American Airlines. But having allows you to then filter out measurements once they're computed. So for example, let's say that we wanted to ignore airports that have lower than 100K or 100,000 flights per year. This halving does exactly that. So what it says is it allows us to compute the aggregate, but then we can put a condition on it to throw it out because we don't really care about it. It's just too small. So that's again a very very helpful command, which is going to is going to go ahead and allow you to drop that data out. We also have the ability to join data across tables. So there are cases, I said generally speaking, we want to have a big fat table. We tend to denormalize data. This is just more efficient. It works particularly well when data is widely distributed. But there's no reason you can have data in multiple tables. It's great. ClickHouse is not going to, you're not going to be charged for it, and you can do as many tables. We typically make them, as I say, they become what are called dimension tables. So they tend to be smaller than the fact tables, but you can have as many of these as you like. So here's an example. We have the on-time data and we have the airport, which is characterized by an IATA code. That's like SFO or EWR. So, and in that case, what we're going to do is we're going to do a join. So if we wanted to, this is an example of what we're trying to, of where we're trying to select. Let's see, we're counting up flights. So we're counting up the number of flights to particular airports, and we'd also like to show the airport name nicely. So we're going to join on, and this is an example that the join doesn't quite, the data types are not quite the same, so we have to do a little bit of a conversion. And then we have a join type. So by default, we'll only see the rows where there's an exact match between the values, where we have an airport and it has a, the airport table has a value and the on-time table has a value. There are cases where we don't want that behavior to be correct. Let's say that the airport table were incomplete. We might want to have values come back even if we can't find the airport name. So the right join does that. It is going to match against the data in on time, even if we can't find an airport for it. So in fact, that's a little bit tricky. So here's some examples of how it really works. So when we do the joins, and this is pretty standard join syntax that ClickHouse also has some other joins that aren't supported by most databases, but the standard join types that you get in databases include the right join that we saw. We saw it sometimes called the right outer join. So here we have the join. So, and if we do left outer join, we're going to get all the airport rows plus any matching on-time rows. So even if there were an airport for which there were no flights, we would still see it. The full outer join, we're going to get everything. We're going to get all the rows that match. We're also going to get airports that don't match and on-time rows that don't match. Inner join, that's the default. That's only the rows that match on both sides. And cross join, which you want to be really careful about doing. It's just going to match every row with every other one. And so there's no key that's uniting them. It's sometimes called a Cartesian join. So if you have table X and you have table Y and you want to just get all the XY combinations, that's how you do it. It's called cross join. So these all work very well. One thing that I don't think we talk about here, in ClickHouse that I will highlight is with ClickHouse, you want to make sure that the left side table is small. So let's go back. Excuse me, the left side table is the big one. Let's just go back. Oh, here's the examples of data. This one right here. So we call this one where we have from on time. Oh, that's the left side table. So that's the first one that appeared. We want to make sure that that is that table is the large one. Otherwise, the joins may be inefficient. So these definitions are sometimes kind of hard to remember. I have difficulty remembering them myself. So what I do is I actually put some examples in with data, and then I can test them. And you can create little tables. If you can't remember this, it's really easy. Just create a left and a right table. And here's an example. This shows the exact behavior that you expect. So we're joining left and right. And here they are. The inner join just gives you the two that match. So only ID2 is present in both. And then the left outer join shows you that it gets the left table plus all the matching ones. Right outer join gets you the right table plus all matching ones. And then the outer join gets them all. So these are very simple to illustrate using tables. And ClickHouse supports these all really well. So there are many other join types. We cover them in ClickHouse 101. You can look them up. But for example, there's an anti-join, which will give you the values that are not in either table, stuff like that. So it's quite useful. And here's the results in real life. So we have airports. That's the right join. So this shows you the airport name, and you can use it again pretty much as you would in any other database. Let's see. So a question here: ID 0 by default when there's no match. Yes, yeah. Great question. So yeah, we have an observer. Thank you, Ali. That's a really good question. We have a question here. How did this? So here we see the non-matching rows. So the left, and you'll see you get the ID value. And what we do is we put in the default. So ClickHouse will just supply whatever is the default value for that column if it can't find it. For an integer value, it's going to be 0. For a string, it's actually going to be an empty string. ClickHouse is one thing that's important is that ClickHouse, we haven't talked much about nulls. ClickHouse in general we tend not to use null values in ClickHouse. Excuse me. And the reason for that is that if we have a null value, we actually have to have two extra columns or 2 extra files per column to accommodate the null values. So because we basically have kind of the moral equivalent of a bitmap of all the values that are nulls. So we tend to instead just use some standard value like 0 or empty string or something like that. Nulls are tend to be less important in these types of analytical queries. Okay, that was a great question. Here's one more thing. So let's look at this join. This is a really interesting feature. So here we're joining the data. One of the interesting things you can do in ClickHouse is we often do things as subqueries. And there's an important reason for this. While subqueries sometimes, it used to be in ClickHouse, we could only join a right and a left table. And if we had to join more, we had to build the query out with subqueries. That's no longer necessary. ClickHouse can join as many tables as you like, but subqueries have an interesting property that when we're parallelizing the query, if you have this initial subquery, like the example I'm showing here, the subquery executes first, and then what it does is ClickHouse will bring back the data here, which is aggregated, as you can see, because we're doing counts, and then it'll just do the joins on the results of that subquery. That actually can turn out to be phenomenally fast in some cases, because what would happen is if we did the join in the main query, it would force all these rows to drag around the airport name. So this long string would get dragged around with the results until we could finish the aggregation, because we don't know if we're going to need it later. So, we don't know if it's, we know we're going to need it. And well, in fact, we know if we're going to need it, but we have to bring all of the airport names along, which are of course duplicated many, many times. So what this query does is it's basically reducing that to a join on a very small amount of sets, or a very small join on the result sets. And so as a result, it's 2.5 times as fast. So this is a common way to optimize queries. When we're thinking about these very, very large tables, we're always thinking about the fact that we're parallelizing, and that in fact we're trying to reduce I/O. We're trying to reduce the amount of memory. So there's some kind of specific things that we'll do to optimize these queries to make them run faster. And as I said, you can have multiple joins per query. Here's an example. So we will scan them. And one more thing about ClickHouse that I think is relevant is when we're doing the joins, what's actually happening under the covers is different queries, different databases have different ways of doing this. ClickHouse does not have a query optimizer. So ClickHouse can't really, what would happen in Oracle is Oracle would look at this query, and then the next thing it would do is it would go look at the statistics in these tables and figure out what's the right join order to apply and what's the right join mechanism, like a merge join versus a hash join. ClickHouse has no idea. We don't keep statistics. We don't have a query optimizer. Everything is rule-based. So what will happen with ClickHouse is these left side tables, each one will individually get scanned. It will get stuck in a hash table. And then as we're scanning the main table, what will happen is we'll then refer to that hash table and do the join at that point. So it's a little bit different from the downside is that we don't do anything magic to make this query faster. The upside is we don't do any magic. So what you see is what you get. If you don't like what you're seeing, it's pretty easy to figure out what ClickHouse is doing and change it. Unlike the Oracle Query Optimizer, where the first thing I would do is go ask somebody who actually knew what they were doing. So this is a big difference between using ClickHouse versus some other databases. Okay, we're at 90 minutes. It's a good time to do another lab. So what I'm going to do is give you all a few minutes and let you try another lab exercise. These are, the previous one was easy. These are real queries. If you can get all of these, you're doing pretty well with SQL. And anybody who, they're designed for anybody who's had some SQL experience before. You should be able to pull the queries out of the slides. Examples, play around with them in that UI, and then and get the results. What I'm going to do is give you about 5 minutes to try this out, and then we'll come in and start slowly going through the queries, give you some clues, and then we'll wrap up probably about in about 15 minutes, and basically tell you a few more things to learn about ClickHouse, but also answer questions if there are any. So with that, go to it. Try the lab exercises. Once again, just use that play interface. Oops, let's get this. Here's the play interface. So go ahead and press that link. If you're able to connect, you should be able to try these queries, and let's show them so that you can see them easily. By the way, if you're having trouble with something, go ahead and sing out in the chat, or you can ask, open a Q&A, and I'd be happy to answer it. I'm here to help answer your questions. I want to go ahead and share one of the queries, the first one, because this is a pretty easy one. Um, let's go ahead and here's something that if you're using ClickHouse or actually other databases for the first time, one product that I really like is called dbeaver. It's actually, you can see that I use it a lot. So these are all different types of ClickHouse servers that I'm connecting to. It runs very well on Windows, but it's just a nice query tool. And I'm using the open source or the freeware version of it. It also has kind of a nice enterprise version. So here's this, the first exercise was to figure out the number of flights per year. So this is pretty easy to do. We can just run this query. So all I do is put my cursor in on this query, and I'll go ahead and press the run button, which is up here, and boom, bada boom. There's my results. So this just shows us the number of flights that we have in the data set. And as you can see, the data set sort of ends at this point. Well, this is a pretty easy query, just a count, a group by. We can also flip it if we want to see the most recent data first. So we'll go ahead and make it descending, run the query, and there it is. We show 2020 first. We kind of run out of data partway through the year, but 2020 also had a lot fewer flights for reasons that I think most people find pretty obvious. I'll let you chew on a couple more queries, and then we'll give you a couple more minutes, and then we'll start slowly going through some of the examples. So keep trying them. Let me know if you're running into problems, and we'll show you the answers in just a minute. Oh, while we're doing the labs, I got a great question. What BI tool other than Tableau would you recommend for visualizing large time series data stored in ClickHouse? Viewing a billion rows on screen. Okay, so this is a great question. Actually, I would recommend Tableau. I didn't previously, but we've actually developed, Altinity developed a connector for Tableau that as soon as I get off this class, I'll start working on the blog article for it. It's in beta now, so you can use Tableau. You have to use the most up-to-date version, like 2021.1 or something like that to get it. But two others that are really popular are Superset. I showed you an example of that. I love Superset. It's a good one if the people using it are more business analysts, because it supports no code charting. It's really good. If you haven't used it in a while, I definitely check it out. It also has just a blizzard of cool visualizations. There's at least 50 of them now, and the community is super helpful. So I really like Superset. The second one, which is really popular and has been for a long time, is the Grafana. Is Grafana. Grafana is a little bit more focused on operational dashboards. With Superset, you're reading SQL data sources. With Grafana, it also has very good integration with non-SQL data sources. Most prominent is Prometheus. So, and since operational data often tends to land in things like Prometheus, Grafana is a great combination, because you can read from Prometheus, you can read from other types of stores, like InfluxDB or TimescaleDB, and there's also a plugin for ClickHouse. So that one requires you to really know SQL, and in fact, you have to cover cover them. Yes, and there's a question: can I write the names of both tools? Gladly. So here we go. So here's the ones that we recommend. Superset. So and you can check with Preset is a company that that supports this. They have a cloud version of it. They're super helpful. They have a lot of documentation. So so this is supported by preset.io. So go look there. Next one is Grafana, and that's supported by Grafana Labs. So I'm just typing these into the chat. You should see them. Just go to their website. And then finally, of course, Tableau. And that's supported by, well, now Salesforce, but they're an independent unit. Yeah, I'm just learning Tableau. It's actually really cool. What I like about Tableau is, I think if I had to make the trade-off, well, in addition to the fact that there's just a million people who understand, well, maybe not that many, but there's a lot of people who understand Tableau. It's very popular in large companies. Tableau probably has the best. It has the most. Definitely has the most powerful no-code chart builder. So, for example, it understands joins, which is something that Superset does not do yet. But these are all good tools. I recommend checking them all out. Let's do some more homework exercises. So keep the questions queued up. You can put them in the question and answer. I'll get to them. Let's just talk about these queries. So another one was to find the busiest airports in 2017. Let me make sure that was really, yes, measured by number of departing flights. Okay. Here's a query that will do that. So departing flights, that's the origin. So that's what we're going to count, or that's going to be our dimension. It's the origin airport, and count the number of flights. Who's the winner here? This is a top 10 one, or I've done it as a top 10 query. So Atlanta. No surprise to anybody if you're a US flyer, Atlanta is the winner, followed by O'Hare and Denver. And my home airport, SFO, is pretty far down the list. So what about if we want to see the airport name? Well, we can do a join to get that. And this is really just stealing it straight from the example. So we'll do a nice join here. Again, a top 10 query. There we go. Atlanta, the full name is the Hartsfield Jackson Atlanta International Airport. So that's a nice example of a join. Which airport had the highest departure delays? So we're going to be nice, and we're going to show the airport name. So let's go ahead and grab that. And so we will run that query. And what are we doing? So we're taking the average departure delay. We're going to have to group by the origin airport so that we'll get the average computed on the right thing. So the departing airport, we're showing 2017 is the year. We're going to get the airport name because we're nice people and we want to show it. And here we go. And here's the airport. So what's interesting about this is the highest departure delay was in Stillwater Regional Airport, and they had one flight. That's the reason I counted the flights, just to see how many there were. Well, Stillwater is not a very big airport, as you can tell, and I don't know, they maybe had to push a cow off the runway or something, but one flight is not very many. And in fact, what this really illustrates, and this is the key point, with small numbers, you get outliers. So these departure delays are not super interesting because they're at airports that might have special reason where even a small number of delayed flights would have a very large influence on the actual number of delays. So what we can do is focus this on airports that have 100 flights, 100,000 flights per year, and that's where we use this having clause. So here we go, having. So this now we're seeing it for the big folks, and there's no big surprise here. It's Newark International Airport has the highest level of delays. It's kind of famous for it. So I don't know what it is that's blocking their runways. Probably other aircraft, but that's a great example of how to only look at the big folks. Let's see. Which airline carrier had the most flights in a single day? That's a pretty easy one. Again, a top 10. So we're gonna use flight date, and let's go ahead and see which one it was. And I think our winner is probably going to be Southwest here, almost certainly. Yep. So Southwest, and we can see that they run about, when they're running at full steam, they have over 4,000 flights a day. So, and that's an individual hop. That's not the flight numbers get copied around, and they may visit separate cities, but they're each a different flight. And then here's a really interesting one. This final query is, can we show the starting with San Francisco, can we show all the airports that actually any flight that comes from San Francisco or Portland, where did it go and what was the latitude and longitude of the place that it went to? So why would we want to do this? Well, actually a reason that we might want to do this is because we're drawing a map. And so lat long is something this is a good example of something where you're going to want to join on this to build like a geographic display. So we'll run that one, and what we will see is a bunch of flights. And in this case, the order isn't very important. This query I actually developed to do a superset for a superset example where I was showing showing the target airports of all these flights. So those are homework exercises. Let's see. So okay. Oh, here we've got a question from Calvin. We had multiple issues with Tableau using the Altinity connector. So let me just be clear, Calvin, if you could qualify that question. In fact, here, if you don't mind, I'm going to unmute you because you can ask that. We're now into question and answer time, so I will answer them until you get tired. Calvin, I'm going to unmute you because I wanted to ask, were you using the ODBC driver or actually using the connector?
Both.
Oh, can you hear us?
Yes, I can hear you perfectly.
Yeah, so we actually installed the driver, and also we recently installed the ClickHouse ODBC connector. We tried to reach out to Tableau folks, and basically they're saying we don't support ClickHouse.
Oh, they don't. That's because we're actually partners with them, and we are developing this. And it's not in their catalog yet because we actually haven't finished our testing on it. We have and what version of Tableau were you using? Do you know?
2024.
2021.
2021. Okay. 0.4. Do you mind sending me, or you can just send me your email privately? I will follow up with you afterwards to make sure that we get this fixed. That's great. I'm glad you're using it, but and I just want to be totally clear that you're using you were downloading the connector from our GitHub and installing it manually.
Correct. Yeah, we follow the steps that you publish, but that's one side of the house, right? On the desktop for
Yep.
the purposes.
Yep.
And the other issue that we had was when publishing these to the Tableau server.
Got it. Okay. Well, I'm really, really glad you're testing this because this is something where I had to put it out and to see some of these problems. I have a feeling that datetime 64 may not be. So there's just so you have the context on this, there's this big there's this huge test suite that we run, but I have a feeling it doesn't support that data type because that's not a common SQL data type. So it may not even have test cases with it. So this may be something that we have to look into.
Yeah. All right. Yeah. I mean, it's not just the format, the data type for the time, but
yep,
some other issues that are thrown out by ClickHouse that Tableau doesn't.
Yep. Excellent. If you can go ahead and send me your email. The other thing is, if you want to go ahead and log issues on the GitHub projects, if you're using ODBC, you can log, either the connector, you can put them there, or the ODBC driver. We will also act on those, and I will make sure that they get addressed immediately. Because we really want Tableau. I've been playing around with Tableau and I haven't hit problems, but I also haven't been using datetime 64. All
right, sounds good. Yeah, we'll send you our email.
Okay, awesome. Thank you so much, Calvin. I really appreciate that. There's a question here from Alberto. If I want to know all the session open or SQL command or the audit trail in the database. Okay, that's a great question. there is a table, there's something, ClickHouse has a bunch of system tables, and they're in the system database, and they're incredibly useful. One which you can enable, which will give you, I think, most of the information you're looking for, is the SQL query log. So any SQL command that's issued will go into the query log. You can enable it by default for, and there's a number of settings, but what will happen is it'll get copied into this table, and then you can just select them out. So we use that regularly. In fact, unfortunately, I should have had that open so I could see what you all were doing, you know, whether you were having success with your queries, because I would see them in the query log, but I forgot to set up the account, or I forgot the password of the account that allows me to see that. So, so that will help you. There is a feature that we've been working on, which is actually an audit trail. And that audit trail is going to be, hopefully will be merged into ClickHouse fairly soon, that will show significant events like, you know, somebody created a table, or somebody did something that, you know, granted privileges to somebody, that shows you things that are specifically related to security. So the final thing, sessions, I don't know if that's in the audit trail. That I think is one thing that is still a little bit hard to get. I know we can get it out of the logs, but it's a little bit painful. So, but in general, that the query log would be the first place that I would start. So look for the look up query log on the on the ClickHouse.tech website, and I'll show you the link for that in a minute. You'll be able to open it. In fact, that brings up something that I definitely want to show, which is there are more things to learn about ClickHouse, and I'll continue taking questions, but I want to make sure that I get this for people who need to leave. There's a bunch. So ClickHouse is extremely fast, but you can use it most effectively if you know more about it. So for example, figuring out how to optimize these table partitions in sort order. There's, and also reducing column size with compression and codecs. There's system tables that you can consult that tell you how efficiently you're storing your data. There's something called materialized views, which I hinted at. And in general with ClickHouse, when you start, you just select straight off the source table, because ClickHouse is so fast for the reasons that I described earlier, that that's often good enough. And we have there are very large users out there that just select straight off the raw data, and that's good enough. But performance is great. However, if you have services like, you know, I gave an example of where you're rendering a page and you need to get an answer about what to put up on that page from ClickHouse, and you need it in a few milliseconds, then pre-aggregation is your friend. So a materialized view is like an insert trigger that you can have on a source table. So when the data goes in, it will run a query. The most common type of queries is to downsample the data. For example, like if you're showing, you know, events, you know, CPU usage at any given second, you can compute the average CPU usage per hour. And these allow you to get answer. If that's the answer if that's the metric that you're looking at, it can reduce the time to get the query results back by order of 1,000 or more. So this is a really powerful feature. There's replication and sharding, so you can spread the data across multiple hosts. You can split the data. You can subset the data in shards. The shards can have replicas. These allow you to give you, you know, just to have more data that can be loaded into the system, and also spread your reads out. Ingesting data from Kafka, I hinted at that. And then finally, visualizing results using BI tools. The Superset, Grafana, and Tableau. We did a presentation to to a recent meetup, actually 10 days ago, and we'll be posting a blog article on that shortly. But we have a talk that covers all three of those, so you can get more information there, as well as looking at it. Great. So, and then final thing, this is really important, more information. So community docs, these are in the slides. ClickHouse.tech, this is really good. ClickHouse does a very good job on this. There's a ClickHouse YouTube channel. We also have one at Altinity. We have a blog that covers a lot of this stuff. We do webinars. And then of course, if you get really stuck, go look at ClickHouse source code. As we say in open source, use the source, Luke. And so what you want to do is particularly, you can pull the source from GitHub. One of the most useful ways that you can use it is if you're looking for examples, you can go into the tests and you can find examples of all the legal SQL that you can run. I find that very helpful if I'm a little stuck on, like if something is not documented, it might be because the docs are just incomplete, but I can go find a test. Also the C++ code, if you're really curious about how things run and what different table engines do or behavior, you can often read the C++ code directly. It's very readable. Good. So these are all things that you can do. I'll stick around for a few more minutes to answer questions, but I want to thank you all for, for bearing with me on this query, or on this, on this webinar. You can see it's been a long 2 hours, and we'll be publishing a recorded version of it minus the dead space at the beginning, and we'll publish the slides as well. So, and feel free to contact us directly at Altinity if you'd like to find out more. You can come through our website. There's a contact us, and we're pretty quick to respond. And for the folks at Digital, who supplied the emails, I'm just copying them out, and I'll be sending you an email right away. So if there are more questions, please, I'll stick around for a couple more minutes to the top of the hour. Feel free to ask, but otherwise, thanks again, and I hope you enjoyed this presentation.